Hello and welcome to today's problem, 1578, minimum time to make rope colorful. So you have n balloons arranged on a rope and you're given a 0 index string colors, where colors I is the color of the ith balloon. We don't want any two consecutive balloons to be part of the same color. So we can remove balloons from the rope to make it more colorful. Each balloon, like it says here, it has a time where it takes to remove the rope, and we want to return the minimum time to make it colorful. Okay, this makes sense. So what I'm thinking of is having a sliding window where you traverse the array. Like so. So we can have a left and the right here, and then from here what we want to do is we want to keep incrementing the right pointer forward over and over. As we increment the left and the right pointer together, if it's equal to the same one, then if it's not equal to the same one, then we can set, oh sorry, that's the needed time actually. Oops. If we increment the left and the right pointer here, as we increment the right pointer forward, we can check to see if it's equal to each other. And if it's equal, we can set it to make it equal to the next one. Yeah, we can set it to equal to the next one. And if it turns out that eventually the two do equal each other, we can either choose to remove this balloon or the left balloon, or we can remove the right balloon. So depending on what our option is, we can choose to either take the left one, which is the A, or the right one, which is this A. And this will depend on what the needed time is going to be. If we have 1, 2, 3, 4, 5, we're going to know that this balloon, A, is probably going to take less time, so we want to have that one instead. So what we can do for this one is just remove this, and then, or like add this to like the amount of needed time that we need to have. And then we can move this forward. And then otherwise we keep going to the very end until we eventually reach the end of this. So yeah, if this makes sense, I'll go ahead and begin coding it up. We have the left to be equal to the, we want this to be equal to 0. We also want the result to be equal to 0 initially, so we can have this and be equal to 0. Next, we want to traverse through. So for r in range length, so for r in range, we want to start the right one ahead because we want the right pointer. We don't want it to be looking at the same one. So start at range 1, and then from this up into the length of colors, we want to check to see if the colors of the left one is equal to the colors at the right one. If it is, we want to check to see if needed time of the left one is greater than needed time of the right one, then we want to replace it with the right. So we want to do needed time plus equals, if it's less than, if it's less than the needed time for the right, we want to check to see, and we want to add needed time plus equals needed time left. Well, actually, we want to add this to the result. So res plus equals needed time left, and then we move the left pointer and we make it equal to the right. Else we go ahead and just do res plus equals needed time r, because we removed the right one. And then after that, what we can go ahead and do is set the left to equal to the right, and then return this at the very end. Yeah. And yeah, the reason why we're doing the else statement here is if the right one is greater, then you want to have the needed time for the right balloon be right after we do that. Like after we do it, and then we want to set the left to equal to the right, and then move on so forth to keep looking for the consecutive number. So if you go ahead and run this, actually we should move the indentation here, and also check for that. Nice. And then there we go, accepted. And Time complexity should be O of n, because it's a sliding window. You're updating the condition as you keep on moving forward, and so in the worst case, it's O of n, where n is the number of colors in the balloon. So just to ensure that. Okay, yeah, I guess it doesn't give you the option to, but should be O of n. So, and the time complexity, and the space complexity, I mean, is going to be O of 1, because you're not storing anything in the actual memory itself. So yeah, thank you for watching.